So this question asks, what is the Maclaurin series for f of x equals x times e to the x? So the first step is to determine the center, which is always going to be the variable a equals something. For a Taylor series, the series is always centered about a. So it's going to be the sum as n goes from 0 to infinity of f to the nth derivative evaluated at a over n factorial times x minus a to the n. For a Maclaurin series, it's always centered about a equals 0. That's why a Maclaurin series has its own special name over with respect to, well, as opposed to a Taylor series. Maclaurin series is centered at a equals 0. So we know that a equals 0, so the series is going to look like this. The sum as n goes from 0 to infinity of f to the nth derivative evaluated at 0 over n factorial times x to the n. So now the second step is to determine to differentiate the function several times, because the sum is f to the nth derivative. F of x is x e to the x. F prime of x is the product rule, so it's e to the x plus x e to the x. F double prime of x is e to the x plus the product rule again, e to the x plus x e to the x, or 2e to the x plus x e to the x. F triple prime of x is going to follow the same pattern, 3e to the x plus x e to the x. And I think 3 derivatives is enough for this example. For some examples, you might have to do more than 3 derivatives, but for this one, I think it'll be enough. So the third step is to plug the differentiated f of x's into the Maclaurin series sum. So we have the sum as n goes from 0 to infinity of f to the nth derivative evaluated at 0 over n factorial times x to the n is going to equal f evaluated at 0, plus f prime evaluated at 0 over 1 factorial times x plus f double prime evaluated at 0 over 2 factorial times x squared plus f triple prime evaluated at 0 over 3 factorial times x cubed plus ... Meaning, we have f evaluated at 0 is 0 times e to the 0. F prime evaluated at 0 is e to the 0 plus 0 times e to the 0 over 1 factorial times x plus 2e to the 0 plus 0 times e to the 0 over 2 factorial times x squared plus 3 e to the 0 plus 0 e to the 0 over 3 factorial times x cubed plus ... When we multiply all of these out, we see that we have 0 plus e to the 0 plus 0 times e to the 0 times x over 1 factorial is simply x over 1 factorial plus 2x squared over 2 factorial plus 3x cubed over 3 factorial plus ... When we look at the pattern here, we see we have an invisible 1 right here, and it increases every term. So we have n times x to the n, because this also is the first power, over this is 1, 2, 3, so it's also n factorial. But this answer doesn't match any of the answer choices that are given, so we can cancel out the 1, the 1, the 2, the 2, the 3, the 3, so we're left with 0 factorial, 1 factorial, 2 factorial, which means the pattern changes to x to the n plus 1 over n factorial. And we can see that this is the case, that this follows the series that we were just given, and it matches one of the answer choices, because whenever, excuse me, that's not right, because whenever we plug in 0 to this term here, we get that x to the first power over 0 factorial plus x to the second power over 1 factorial plus x to the third over 2 factorial plus dot dot dot. So this is the final answer.